pencils down, colored pens up. So, let's see what we got. We got 1, 2, 3 brave people. We'll start with David, Kayla, and then Gary. What'd you get?
I got 76.
Okay.
I got 8 and 1.
Okay.
I got 11.
Okay. Okay. So we have 4 different answers. Anyone want to chime in with a different one or piggyback on one of the other ones? Catalina and then Marcus.
I got 1 over 17.
1 over
I mean, 1 and 17.
1 and 7/8.
Like, it seems like in a decimal. But
No decimals. Go ahead and tell me what your decimal is.
2.56.
2.56, okay. No decimals needed. What's the rule?
If this is a fraction, a standard fraction.
Yeah. Okay, so we have a whole bunch of different answers. Amir? 7/10. The correct answer is 5/8 of an inch. Now I'm going to use Kayla's for a second. And it's not meant to embarrass her in any way because I know she tried really hard. I saw her paper. She was trying, just like everybody else. But your answer was what? 8 and 1/8. So I want you to listen to that. And I want someone to tell me why her answer makes absolutely no sense whatsoever. Why does her answer make absolutely no sense? She even realizes why. Amani? Yeah. The space right here in the diagram is bigger than this space, and this is less than 3, so how could that be 8? Plus, there's 2 of them, right? There's 2 spaces. So if there's 2 spaces that are 8 inches, how many total inches is that? 16. Someone tell me why that doesn't make any sense. Chanel? That's wider than the whole paper itself. So it doesn't make sense. So this was not an easy question, but I'll be honest with you, this is nowhere near remotely the hardest type of question you will see over the course of this year. It looks intimidating. The diagram looks intimidating. The numbers are intimidating. And you know what? It's actually a very simple idea. And some of you are going to kick yourselves when you see how simple the idea is. Now, I'm not saying the question is easy. I'm saying the idea is easy. So I'm going to create something different. And this is a problem-solving technique called do a simpler problem. So now I'm going to do a simpler problem, and so I want to ignore what's up there for a moment, and now I want you to watch. And so I'm going to draw a line. There's a line. And now I'm going to duplicate the line using the power of my computer. And I'm going to line them up as best as I can. So they're the exact same distance, okay? Exact same distance. But now watch. I'm going to take this chunk out of this one. Continue watching. I am going to say that this is 20 units long from end to end. I am going to say that this piece is 5 units, and this piece is 10 units, and I'm going to say that the distance from here to here is x. Someone tell me, what is x? Got a bunch of people. 1, 2, 3, 4, 5, 6, 7, 8. Jesse, and then Kaylee. What do you think it is?
5.
What do you think it is? Alex, what did you think?
5.
How'd you get 5?
Because 5 plus 10 is 15, and you add another 5 is 20.
Very good. So this whole distance must match this whole distance. And so if I'm missing one piece, I can figure out that one piece by using the other pieces. So watch what actually happened in this page layout, this publishing issue. All I'm asking for is the distance from here to here and the distance from here to here. but I know all the other distances. This distance is 3/4. This distance is 2 5/8. That distance is 2 5/8. So is that. And this distance right here is 1 5/8. What's the overall distance? Because in this example, I had an overall of 20 and then I had the pieces here. I don't see the overall distance in this. All I see is this. Yasmin? Where do you see that? Oh yeah, it's right there at the top. The distance from one end of the page to the other is 11.5. So take all the individual distances, that's x, add them all together, and it has to equal 11.5. Yes? Does it relate to this?
Yes.
Go.
I figured out how the answer is 5 minutes.
Good.
Just explain.
Well, that's what we're doing, but go ahead.
What I realized is that you have to add these numbers up and subtract it. Like 2 5/8 times 3 would be 7.8.
So not doing decimals, so.
Well, like 7 and 7/8. That's what it means.
Yeah, maybe.
Yeah,
Okay.
And then what happened is I subtracted that from 11.5
Mm-hmm.
and forgot what it was.
Okay. Well, that's okay. And then you did what? Doesn't matter what it was, but then you did what?
Then what happened is that I subtracted it. I had 3/4 and 5/8, and that came and that equals.
That's right. And so you got the right idea, but we're in algebra, and so the whole point is to learn how to use algebra to solve problems. And so what you really did was a simplified form of this. 3/4 plus 2 5/8 plus x plus 2 5/8 plus x plus 2 5/8 plus 1 5/8 equals 11.5. And you'll see right here it says set up an equation and then solve. Set up an equation and then solve. Does anyone know how many steps this takes? Looks nasty, right? How many steps do you think it takes? If you follow algebraic steps. Amir? You think it's 4, Garion?
I think it's 3.
You think it's 3, David?
2.
2, Adrienne?
8.
I think it's 8 steps. It's 3 steps. Combine like terms. These are all like terms. 1, 2, 3, 4, 5. Combine like terms. That's step 1. X and x are like terms. That's still part of step 1. It becomes a 2-step equation. Solve it, and you're done. So, I'm not saying this is easy, but this is not beyond your abilities. And you will see questions like this again and again. Any comments or questions? Good. So draw a line across your paper. Today is lesson 2-1. Of course, you already have that written across the top of your paper. And we're going to be focusing on graphing and writing inequalities. So we are entering chapter 2. Chapter 2 is all about inequalities. By the end of chapter 2, you will have explored some very complicated ideas. Let me say that again. By the end of chapter 2, you will have explored some very complicated ideas. Very complicated. If you thought absolute value equations were difficult, wait till you do absolute value inequalities. Very challenging. But to get to those challenging ideas, we need to lay some foundation concepts. So today we're going to focus on identifying solutions of inequalities and writing and graphing inequalities. So we are doing the basics today so that we can work our way towards the complex. So let's start with some basics. What is an inequality? It's a statement. Just like an equation is a statement. However, the major difference is that an inequality refers to two quantities that are not equal. And you already knew that because the prefix in means not. We compare the quantities using symbols other than the equal sign. These are the symbols we will be using. They are virtually all the same with the exception of the one all the way to the right here. And they actually all mean almost the same thing. So, let's start over here. A is less than B. But here's the thing. This symbol and this symbol are actually the exact same symbol. And you read it exactly the same way. You can read this A is less than B, or you could read it B is greater than A. This is A is greater than B, but you could also read it B is less than A. So you just have to know how the symbol works. When you were younger, your teacher might have taught you the alligator. Give me a thumbs up if you were ever introduced to the alligator. Good. Put your thumbs down. If you want to use the alligator, go ahead and use the alligator. Let's see who actually remembers it accurately. What does the alligator do? Cheyenne? It eats the bigger number. So you have to remember that. If you don't remember that, then you're going to get them all wrong. Here's the way I teach it, and then you can choose which method you want. Pick one method. This is an arrow with a point on it. The point always points to the smaller number. Always. So if the point is facing this way, that's the smaller number. If the point is facing that way, then that's the smaller number. It's just a different way of saying it. So you want to use the alligator method, use the alligator. You want to use the point method, use the point. I don't care. Pick one of them and stick with it. So now we know how to read these symbols. Now introduce this more complicated symbol, but it's really not a big deal. These are the same as these, except they have this bar underneath. The bar is half of an equal sign. So the bar means or equal to, or equal to. This last symbol, we're not going to use that much, but you need to be aware of it. It's an equal sign with a slash through it, and it just means that the two values are not equal. Any comments or questions so far? So our goal by the end of today is to be able to identify a solution to an inequality. A solution to an inequality is a value that makes the inequality true. And we're going to spend most of our time today working on that. We will spend some other time working on graphing and identifying the meaning of a graph. The ruler is for you to draw straight lines, and that is it. Does anyone have any questions so far? So, the first example we're going to do looks like a beast of a question. We're going to use a technique to solve a problem. We're going to use today, we're going to use tonight, and then we're not going to really use very much again. But the technique is important because we're going to get a whole bunch of different ideas from the one technique. In fact, we're going to spend most of today on this one example. We're going to spend much more time on this one example than on any other example or checkbook. So you have to get a lot out of it. If we're spending time on it, you got to get a lot out of it. So example 1. Here's the question. Describe the solutions of 60 minus 10x is less than or equal to 20 in words. So the question or the statement is describe in words the solutions of that. So what do I mean by solutions? So we're going to clarify that first. We're going to pick numbers in place of x, to put in place of x. And then we're going to simplify this side, and we're going to see if it's less than or equal to 20. Could I have a volunteer pick a number less than 20? Just any number less than 20. Laurel? I'm sorry? 3. 3 is less than or equal to 20. Is that a true statement? 3 is less than or equal to 20. Is that a true statement? Give me a thumbs up if you think that's true. Yes, of course it's true. 3 is less than or equal to 20. It's less than it, so it meets the condition. Can I have another number less than 20, please? Any number. Amir? 19. 19 is less than or equal to 20. Give me a thumbs up if you think that's true. Yes, of course it's true. 19 is less than 20. Why aren't you putting a thumb up? Okay. Can I have a number that's not less than 20? Michael? 25. 25 is less than or equal to 20. Is that a true statement? It's a false statement. So that's what is meant by true and false. Okay? So we are going to explore this in great depth using a table system. So here's what you need to draw out. I've set it up for you already. Do not use your ruler for this because I don't want perfect lines for this. I don't care about perfect lines. But it shouldn't be a mess. Here's what you need to draw. 4 rows, 1, 2, 3, 4, and then 7 columns. 1, 2, 3, 4, 5, 6, 7 columns. Take a minute and a half to do that, and then we're going to get to work. Take a few seconds to finish. Anything you don't have set up, you'll fill in as we work. So now let me explain how the table works. The top row is all the values for x that I picked from my head. I am not going to tell you how I picked them. One of your jobs as a high-level thinker is to figure out how I picked them. I'm not going to tell you at all. I'm not going to tell you today, and you're going to have to figure it out. And tonight, you're going to actually have to do questions like this, and you're going to have to figure it out. So these are all values for x that we're going to plug in. So then the second row of the table is the left-hand side of the inequality. And so what we're going to do is we're going to plug this number in, we're going to find its value, and we're going to write the value right here. Then we're going to do it for 0, and then we're going to do it for 3, and so on. Then we're going to put the value from here into the inequality and ask the question, is it a true statement? If it's true, we will write a yes. If it's false, we will write a no. And what we're trying to see is which of these numbers are solutions to the inequality. Any questions or comments so far? So we'll start out slowly and then we'll work our way to a little bit faster. So now take the -3 and we're going to plug it in. So here's what we're going to write. 60 minus 10 times -3. And go ahead and use your mental math abilities or calculator or something and find the value of 60 minus 10 times -3. Give me a thumbs up when you got it. Remember, thumbs up system is like this. I got 5 people, 6 people. Good. Put your thumbs down. Alex, what is it? 30. Gary, do you agree? You agree? Amir? What do you think it is? Oh. David, what do you think it is?
30.
30? 90? Yeah, so we're having issues with our adding and multiplying. Yeah, it's 90. And unfortunately, I'm not going to sit here and give you instruction on how to do that. And it might make you a little uncomfortable and a little bit nervous. But you're in Algebra 1 Honors, and it's expected that you know exactly how we got 90. And if you don't, you might get uncomfortable and upset, but you're going to have to go home and figure it out. Or come to CARE, and come to CARE with Ms. Thiessen and work on it there. Or go online and find some practice. So, the value of this expression when x is -3 is 90. So now we're going to plug it in. 90, is that less than or equal to 20? And we're going to put a question mark right above that. Is that a true statement? Give me a thumbs up if you think that is true. Okay, because nobody put their thumbs up, I'm assuming everyone thinks it's false, and that's correct. So -3 does not work. So it is not a solution. So -3 is not a solution. Let's try 0. So we'll plug in the 0. 60 minus 10 times 0. Go ahead and mentally figure that out. It should take you 5 seconds or less. What does that come out to? Give me a thumbs up if you've got it. Cheyenne, what is it? I'm sorry? 50? What do you think? Oh, we're disagreeing again. Yasmin? It's 60. Of course it's 60. -10 times 0 is 0. 60 minus 0 is 60. So, of course, it's 60. No disrespect meant to anyone who didn't get that, but we're way beyond this. So now plug in the 60 into the inequality. 60. Is that less than or equal to 20? Give me a thumbs up if you think that's true. Because no one put their thumbs up, I'm assuming everyone thought it was false, and you were right. It's false, which means 0 is not a solution. Let's try +3. 60 minus 10 times 3. What does that come out to? Give me a thumbs up when you got it. Same people. Amari, what'd you get? Yasmin, what'd you get? Yes, of course, it's 30. Very good. And so plug that in. 30, is that less than or equal to 20? Give me a thumbs up if you think that's true. It is not, so 3 does not work. So we've tested out 3 numbers that I picked, and none of them work. None of them work. Let's try 4. 60 minus 10 times 4. What is that value? Adriana?
20.
Amir? That's 20. So now plug that into the inequality. 20. Is that less than or equal to 20? Give me a thumbs up if you think that's a true statement. So now we see some thumbs up. Yes, that is true because of the bar. That bar, or equal to, means that the two sides could be equal, and so yes, this is true. And so we found our first solution. 4 is a solution to the inequality. Now here's where things get a little weird, and what makes inequalities more challenging than equations. We spent the whole first 3 weeks of school studying equations and solving for 1 or sometimes 2. Over here, I'm in the middle of grading your tests, and so I could pick up someone's answer sheet, and it's a list of 1 solution, 1 solution, 1 solution, and on the back, there's a few that had 2 solutions. But no matter what, it had 1 or 2, or sometimes it had no solution, right? But now, inequalities don't work that way. Inequalities can have many solutions. So we found one of them. So now we need to test more to see what is actually happening. So now we're going to test 4.1. 60 minus 10 times 4.1. What is the value of that? Gary? That is not 10. I'm not sure how you got 10. You're going to kick yourself when you hear it. David?
19.
That's no. Yasmin? It's just 19. So now plug that into the inequality. 19, is that less than or equal to 20? Give me a thumbs up if you think that's true. Good. Yes, that is true. What do you think the answer to the last column is going to be? What do you think? Just take a guess. We didn't even do it. Give me a thumbs up if you think it's going to be true. If it's going to be a yes. So some of you think yes. Some of you not sure. Kaylee, why do you think it's going to be yes?
Because the top one, where it was 1960, is going down.
Okay. So these numbers are doing what? Kaylee, these numbers up here are doing what?
No, the one below.
I know, but I'm asking you, what are these numbers doing? Well, you were saying something about these numbers. These numbers are, and what are these numbers doing? Right, so as these numbers go up, the value goes down. And so you're predicting that that number is going to make it go down again, which will make this a yes. And that is actually exactly what happens. This ends up with negative 60. Negative 60 is less than or equal to 20. And so that is a yes. But we did a whole bunch of work. You were supposed to learn a whole bunch of different things from this. One, you were reinforcing how to find a solution and how to test it. That's how you test a solution. We talked about truth. Is this true or false? We talked about solutions. Yes, it's a solution, or no, it's not a solution. Whole bunch of ideas from this one question. But here is the most important. We didn't even answer the question yet. It says describe in words. And so now here's the thing. We have to take what we figured out. We figured out that this is a solution, this is, and so is this. But now we can make an assumption. We can now broaden it and say that x will be what? Put it into words. Gary, you think you can do it?
X is equal to 4 or higher.
Okay, so, but how do we put that into words? You're absolutely right. So, x is, I'll start us off with this part. All numbers, Adriana? But how do we say that using these types of words? These are the words we're using. So go ahead, Adriana. X is all numbers. Greater than, and what is she missing? What is she missing, Jesse? greater than or equal to, and that's important, 4. X is all numbers greater than or equal to 4. Any comments, questions, concerns about putting it all into words? So when I say words, I'm talking about specific types of words. Okay? We want to use these terms from here. Any comments, questions? All right, so now I'm going to turn you loose on your own. Checkpoint number 1. You're doing this on your own. I've given you a much easier inequality so that you can focus on the process. But remember, the goal is to write in words a description of the solutions. So I'm going to put 3.5 minutes on the clock. 3.5 minutes, go. All right, so I'm going to start actually in an unusual way. I'm going to start at the bottom with the solutions. So let's see, was -3 a solution? I need some volunteers. Jesse, what do you think? Stacy, do you agree? No, it was not a solution. What about 0? Is that a solution? Isabella? No, it was not a solution. What about 3.9? Was that a solution, Alex?
No.
No, it was not a solution. What about 4? Was that a solution, Yasmin? No, it was not. What about 4.1?
You just did it.
Adriana?
Yes.
Yes, it was. Oops. And what about 5? Amir? Yes, it was. So now you have to put that all into words, but let me reveal the rest for you so that you can see the rest. Here were the values and the inequalities that you should have had. So what were the words that you used to describe all the solutions? We'll start with Cheyenne, and then we'll go back to Yasmin. Go ahead, Cheyenne.
All the solutions I put x is all numbers greater than 4. No, x is all numbers greater than 4.
Okay? Okay, so that is actually the best way to say it. X is all numbers greater than 4. Any comments, questions, or concerns? So that was, we've got quite a bit more to go, but that was the, I'll put in quotes, the challenging stuff of the day. The rest is, again, foundation work, basic skills that you need to even move forward. And so the rest of the time we're going to talk about graphing, how to graph an inequality, and then how to interpret a graph of an inequality. So now you're going to need your ruler. So, now, I'm going to say something and then I'm going to clarify. You do not need to copy all of this. Copy what you feel like you need to copy. Read, and yes, you're going to have to skim and read quickly. Now, when I say copy what you think you need to copy, that doesn't mean I'm tired, so I don't want to copy anything, so I won't copy because Mr. Gao said I didn't have to. That's not what I'm talking about. What I'm talking about is, if you already know this, don't copy it. If you don't know it, then you need to write down something to help yourself. I think many of you already know this, but I'm not sure. So, inequalities like the ones we've looked at and like this here, 3 plus x is less than 9, has so many solutions that listing them is impractical. If I asked you to list all the solutions to that inequality, you would spend the rest of the day doing it and you wouldn't finish. Literally, you would sit there writing numbers over and over and over again, and that's it. That's not fun. So we use a different technique. We use a picture. So here's how the graph works. We put a circle on top of the starting point. There are 2 circles. There's an open circle and a closed, and I'll explain that further in a moment. Then we shade the number line in one direction, either to the left or to the right. The shading represents solutions. So for example, this right here is a solution to the inequality. The 2, 3 plus 2 is 5, 5 is less than 9, that's a solution. There's 1. 3 plus 1 is 4, 4 is less than 9, that's a solution. In fact, every point along the line, anywhere here, and I could keep going all the way here, anything is a solution to that inequality. So your shading needs to be clear, and you must put an arrow on the end because the arrow indicates that it goes on and on forever beyond the number line. Now, open circle versus closed. If we have x is less than 6, that's going to be the open circle because 6 is not one of the solutions. But everything immediately left of 6 is a solution. But what if there was a bar underneath? If there's a bar underneath, what do? Alex? We shade it in. And so that's the closed circle. So you have to know the difference. So now I want you in your mind to fast forward to a quiz. You're going to have a quiz next week. And I want you to pretend that I ask you on the quiz to graph that. And this is what you give me. Am I going to mark it correct or incorrect? Jesse? I'm going to mark it incorrect. And that's tragic. Because this shows me that you definitely know what you're doing, but this shows me that you did not pay attention to details. And I've been saying that quite a bit lately, is that algebra is about the details. And missing that detail is unforgivable. So you cannot miss it. So if it has a bar underneath, you fill in the circle. If there's no bar underneath, then you don't fill in the circle. Any questions about that? Now let's take a look at all the different possibilities. Don't copy everything. Copy what you think you need to copy, or just sit back and absorb it and digest it. But if you're staring down at your desk or off in another world, then you're not doing any of the options. So, here's all the possibilities. There it is written in words. Here's how we write it in algebra, and here's what the graph looks like. So let me point out a few particulars. Less than, open circle, shaded to the left, because x has to be less than, and all the small numbers are to the left. No bar underneath, open circle. X is greater than, all the greater numbers are to the right. Bar underneath, closed circle. Bar underneath, closed circle. Any questions about the basics? So let's get into graphing. So now you're going to do it yourself. So we're going to do a couple together. So I need you to write example 2, m is greater than or equal to 3/4, and then I need you to draw a number line, and I'm going to demonstrate how to do that going over to my whiteboard with my giant ruler. And here's what you're going to do, and you do it quickly. It's going to take you 10 seconds. You take the ruler, and you could use the inch marks if you want, and the inch marks become the tick marks on the number line. So watch this. I'm just going to hold the ruler, and I'm just going to put a mark, mark, mark. I'm just going to mark it up, and then I can move the ruler up and draw a line through it. And there I have a number line. Put an arrow on either end, no big deal. You can even do it completely by hand. Watch this. I can estimate it pretty well. Draw a straight line, and then put a line, and then estimate. It's pretty good. This would not be acceptable. That would not be okay. So, how to graph. So, the number that's in the inequality will become our starting point. So the 3/4 is significant. We're going to put the 3/4 somewhere on the number line, and it does not matter where we put it. That's an interesting thing about number lines, is it doesn't matter where we put it. What matters is what we put after it. So we can put the 3/4 all the way over here, we can put it all the way over here, but we might as well put it somewhere in the middle. So that's going to be the 3/4. Now you must label at least 5 tick marks. At least 5. So putting one label is not good enough because we don't know the interval. So let's do this. What should go here? What should my label for that tick mark be? Chanel? 1. So we're going to put a 1 right there, but now pay close attention because here's where it becomes more challenging. What is the distance now from here to there? What's the distance, Kayla? The distance is 1/4, which means that we just established all the distances to be 1/4. In other words, we cannot put a 0 there because that's a distance of 3/4. 3/4 back to 0 is 3/4. That's not okay. That would be a false representation. So if we go 1/4 this way, we have to go 1/4 that way. And so what number must label that tick mark? Jesse? Very good. I love the way you said that. 2/4, but we write it as 1/2. Now keep going. Go another 1/4 this way. What is our label for that tick mark? Gary? 1 1/4. Very good. Or you could put 5/4 if you wanted to. And then what would be our next label for that tick mark right there? Yasmin? 1/4. Very good. So you actually have to pay attention to how you're labeling. Luckily, most of the time, it's easy. You just have to do 1, 2, 3, 4, or -1, -2, -3. But you're going to have to do fractions sometimes. So that's just labeling the graph. Now we're going to actually do the graph. We need to put a circle on the 3/4. Is it going to be an open circle or a closed? Give me a thumbs up if you think it's going to be open. Couple people, okay, give me a thumbs up if you think it's going to be closed. Okay, everybody else. And the person who originally put their thumb up changed their mind. It's going to be closed because we have a bar right here. Bar means closed. But now we have to shade. And we have to shade either all the way to the right or all the way to the left. And so here's what you're going to do. If you think we need to shade all the things over here, you're going to lift up your arm and point towards the wall. If you think we need to shade everything over here, pick up your arm and point towards the door. So everyone, point in the direction you think we need to shade. Try not to smack the person next to you. So I got a bunch of people pointing that way, and I got a bunch of people pointing that way. Okay, so we do have some disagreement. Most of you are correct. We are going to shade to the right. Because m is greater than, and all the numbers that are bigger are to the right. Does anyone have any questions on how we constructed that graph?
Cool. The ones that are bigger always go to. which
Where are
is
the
bigger?
bigger numbers? Is this number bigger than that one?
Yeah.
Okay, what number would be like way over here?
3, 4.
Yeah, exactly. So those numbers are getting bigger and bigger, and so that's why we're shading that side. Okay, good question. All right, any other comments, questions? All right, so, excuse me, let's see it again, but with a slightly more complex scenario. So go ahead and copy the question and draw your number line. That should take you a minute. All right, so we've been graphing, or we graphed one and we saw a few other graphs, but all of them said the variable, then a symbol, and then a number. And now we have a slightly more complex situation, but it's really the same thing. We need it to say t is less than a number. So I need a number here. So we have to simplify this. So go ahead and simplify. Should take you 10 seconds or less. You should be able to do it completely mentally. What does it come out to? Cheyenne? Okay. Keshape, what did you think? Okay. Chanel, what did you think? -2. What did you think? -2. Catalina? -2. I'm confused. 3 plus -1 is 2, and 2 times 5 is, so where are you getting -2 from?
Michael said distributive.
Well, distributive property would still get you the same answer. 5 times -1 is -5. 5 times 3 is 15. 15 and -5 is 10. Either way, you get the same answer. But we don't need to use distributive property here. We use distributive property when there's a variable. When there's a variable, we distribute. When there's all numbers, simplify and then multiply. So we don't need distributive property right now. That's for when we have an algebraic expression. This is just a numeric expression. So t, unfortunately, since we couldn't do it, t is less than 10. So really the point here was graphing, so let's focus on that. So now we need a 10 somewhere. Put it wherever you want. You can put it here, you can put it here, put it over here. It doesn't matter. But what matters is what you put next. What should go to the right of 10? What should be right there? Gary? A 12? That's the next number? I'm confused. You're jumping by twos? Okay, well, indulge me for a second. What would the next logical number be? 11, good. So I could put an 11 here and then a 12 here, but since they're two-digit numbers, it starts getting a little crowded. So what we can do is skip over the label and just label the next one. Skip over this label and label the next one. That's still an 11, we just don't write it. That's a 13, we just don't write it. And this would be 8, and this would be 6. Now, Garion, what you were doing was when you have big numbers that you're dealing with and a little bit of limited space. So if you had a number line that was only this big, and you had to fit in a bunch of things, then you would want to go by twos so you could fit in a lot of information. But we have a big giant number line, so there's no reason to do that. Now we need to put a circle on the 10. Is it going to be open or closed? Give me a thumbs up if you think it's going to be open. Okay, some of you think it's going to be open? Yeah, it's going to be open. Now we need to shade half of the number line. Are we going to shade to the left or are we going to shade to the right? So pick up your arm and point in the direction that you think we're going to shade. Which way do you think we're going to shade? Everybody pick up your arm and point. So now everybody is on board. We are shading over here. You can put your arm down. And you must put an arrow on the end to indicate that it goes on and on forever. So comments, questions about graphing? Yes, Marcus.
I have a comment.
Go ahead.
Whatever the sign is going, if the sign is open, I would go the opposite side. The sign is going.
Okay, so what Marcus is pointing out is something that a lot of teachers say, but I'm going to hold off on it because I'm behind schedule, and that's my fault. Okay, so we've got enough done that you guys will be fine on your homework. The only other thing we were going to do was, now looking at a graph, write the inequality. But that's the easiest thing out of all of them. So that's the last piece. So we're going to close out the lesson. You're going to draw a line across your paper, of course. Excuse me. Draw a line across your paper and write homework. Practice B worksheet. On the front, you're doing numbers 1 through 14. On the back, you're doing 1 through 4 for a total of 18 questions. And you're going to have a quiz next week. I'll tell you more about it.